What do leave plan of cosmologists have tracked down utilizing our new 10 billion toy? It will be a long time before that task turns into a reality if it goes as expected. The excursion to Proxima B will take about 20 years, so practically, it will be quite a few years before we can affirm if there is, without a doubt, life on that planet. The age-old inquiry is, are we really alone in this universe? The James Webb Telescope has found some alarmingly humanesque things far away from Earth that lead us closer to the answer. Our quest for life beyond us has been rampant throughout every human civilization, to such an extent that we have a great many media, writings, and hypotheses regarding this matter. Our miracle with respect to our place and dejection in the universe has been steady, as though it is imbued within us to continuously look for a buddy, no matter how outsider-like we could actually be. We are finding increasingly close to the solutions we really need. However, are they genuinely the answers we are searching for, or are they substantially more unnerving? Join us as we explore the most recent discoveries in the realms of worlds and planets on the mission to find something we could actually not be ready to observe. Lights far away. Researchers have found what could be the most momentous revelation in history back in 2021 when the James Webb Space Telescope was scheduled to launch. An extremely intriguing theoretical inquiry was raised about the capacities of our technology. The question was whether, in the future, our telescopes could identify artificial light on another planet, for instance Proxima B, the nearest exoplanet to Earth. Proxima B, around 4.25 light-years away, was accepted to be tidally locked with a long-lasting day-side and night-side, like our moon. A theoretical mechanical civilization on Proxima B could move intensity and power from the day-side to the night-side using photovoltaic cells that produce power out of starlight. Hence, in a paper with Manasvi Lingam as one of the analysts, it was shown that significant illumination from the day-side by solar panels could be distinguished with future telescopes. Since JWST was further developed, it would permit us to expand our quest for artificial lights to tenable exoplanets like Proxima B. Now, in 2024, it is conceivable that the James Webb Space Telescope did just that. Utilizing its higher sensitivity and greater range of abilities, the JWST could have potentially found the lights we were searching for and possibly thrust us into another great wave of human development. However, first, let us dive into the universe of planets and exoplanets to figure out how this was indeed even conceivable. The James Webb's mission investigates Proxima Centauri B's secrets. From the beginning of time, people have pondered the concept of the universe. Who we are, where we come from, and where we go. These are normal yet incredibly troublesome questions man has attempted to answer since he acquired consciousness. Now, in the period of outstanding technological advancement, one contemplates whether we are any closer to any of the above questions. If you were to ask a philosopher, he would most likely say we are currently at level 0 of understanding ourselves in the universe. However, ask an astronomer the same thing and watch him bounce up and down in fervor as he races to tell you the most recent discoveries humans have made about the universe using their clever devices. These instruments, albeit not paid much regard by the normal public, are straightforwardly a sign of human advancement itself. We now have the world readily available, and it is time we move forward and get the universe at our fingertips too. One such method for doing that has been found by researchers and cosmologists. It is through the technology we harness. A particular formation of that said technology is now responsible for the new discovery of what may be light on an alternate planet light-years away. Yes, we're discussing the James Webb Space Telescope. The James Webb Space Telescope is the creation born out of the traditions of human endeavors into space to answer some ever-present questions. Are we alone? Who's out there? Where do we start and where do we end? Well, this infrared space science device has already begun answering these questions, albeit to some degree. First, you could end up asking, what even is Proxima B? Proxima Centauri B, or just Proxima B, is sometimes referred to as Alpha Centauri C. It is a super-Earth exoplanet, and it orbits a M-type star. Super-Earth exoplanets, bewildered as they may be, do not stress, since this video will guide you through all your burning questions. Super-Earths are a class of planets that are larger than Earth but lighter than ice giants like Neptune and Uranus. They are genuinely one of a kind. They can be made up of gas, rock, or even a mix of both, and their sizes can vary from 2 times the size of Earth all the way to 10 times its mass. They truly put the super in super-Earth, huh? With respect to Proxima B, it is a super-Earth and an exoplanet, meaning that it is a planet that orbits outside the solar system. The very first possible proof of an exoplanet was viewed as in 1917, although it managed to work up little interest and acknowledgement. However, in 1992, the first confirmed discovery occurred, which left researchers confused. Another exoplanet, an alternate one which was first identified in 1988, was confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems. Out of them, 896 systems had more than one planet. These brilliant discoveries are circling an M-type star. Right now, to make sense of the M-type star, you need to understand the red dwarf. A red dwarf is the smallest type of star in the main sequence, hence the name. In the neighboring areas of the Sun, red dwarfs are by a wide margin the most common kind of star to be found in the Milky Way. They have extremely low luminosity, and since luminosity is one of our primary instruments for planet recognition and other types of observations, red dwarfs are not that easy to notice. These tricky stars have variable definitions and names depending on their temperatures and sizes. For instance, M dwarfs or M-type main sequence stars yield a maximum temperature of 3000 K, thus getting their name and attributes. Returning to Proxima B, its mass is known to be equivalent to 1.07 Earths. Strangely, it only takes 11.2 days to complete one orbit of its star compared to our 365.25 days. You can gauge the size of the star. Proxima B is circling stunningly under the measurement of the whole electromagnetic spectrum. The star has an overall luminosity of only around 1.6% that of the Sun. Also, in the visible light spectrum, its luminosity appears to dim significantly more. As it seems fainter, it only illuminates 5 to 6% of the Sun's brightness in the visible light range, transmitting an essentially lesser amount of light energy when compared to the Sun. More than 85% of its transmitted energy is in the form of infrared radiation, circulating about 0.045 to 0.056 Australian dollars away from its star. Proxima B's discovery was announced way back in 2016. You may be asking, why Proxima B? With a multitude of stars, planets, and systems, why are we so focused on this specific heavenly body? Well, there are a couple of reasons that add to the strong fascination scientists have in this place. As a matter of first importance, Proxima B is the closest known star to our Sun. By definition, although 4.2 light-years is a significant number to us Earthlings in the grand scheme of the universe, it is a simple blip. So why Proxima B? Our nearest known star is high up on the priority list right now. It is also part of the triple star system called Alpha Centauri, and in spite of Proxima's low luminosity, the actual system appears as one of the brightest groups of stars in the night sky, only behind two others called Sirius and Canopus. Anyway, the most intriguing thing about Proxima Centauri B is that it could possibly be livable since it falls under the habitable zone. The conceivable outcomes surrounding the star are endless, and thus astronomers have taken on the campaign to explore the depths and limits of the potential of the star. That is where the James Webb Space Telescope comes in. The four critical objectives of the JWST are to look for light from the first stars and worlds that formed in the universe after the Big Bang, study universe formation and development, figure out star and planet formation, and to concentrate on planetary systems and the beginnings of life. As the JWST proceeds with its investigation of the said exoplanet, we get increasingly close to the culmination of these missions from SII to exoplanets, looking for extraterrestrial life. So what precisely is said? One could ask, considering that humans have forever been an inquisitive species, poking and prodding into literally everything that moves and doesn't move, it makes sense that a journey like SE would appear on such a massive scale. Imagine that God has orchestrated a grandiose cosmic treasure hunt, but with a bend instead of gold. We are entrusted to be on the lookout for signals, more specifically electromagnetic whispers from human developments beyond anything we could ever imagine. SEI is short for the search for extraterrestrial intelligence. It is like the world's most high-stakes game of hide-and-seek, but played in a cosmic scale where entire galaxies could be potential players. Space itself is vast and full of possibilities that humanity is still on the cusp of realizing. Finding intelligent life outside our own is practically a race against time, and while we may be uncovering the real essence of this prospect, we need to be extremely cautious as we may be looking into the void. In the words of Carl Sagan, the universe is a pretty big place. If it's just us, seems like an awful waste of space. In exploring the conditions of Proxima B, the exploration of the capabilities of the James Webb Space Telescope and the search for extraterrestrial intelligence are now putting us on the brink of a whole new paradigm. We are searching for extraterrestrial life, and who knows what that could mean for humanity.